Diving into Android and Kotlin development, it can feel like just a huge amount of information coming at you.
Oh, absolutely. It's vast.
So, for this deep dive, we've tried to distill things. We've pulled from, well, my own notes, the official docs, some mobile system design ideas, really aiming to cut through that noise.
Right. And our goal today is to give you a really focused, efficient grasp of the core Android and Kotlin stuff.
Yeah.
Think of it like a shortcut,
Mm,
getting you to what really matters without getting totally bogged down.
exactly. And to help us navigate all this, make sense of it, I'm really glad to have our expert here today.
Happy to be here.
Okay, let's unpack this, starting right at the foundation. Yeah, Android apps.
Let's do it. So
Yeah.
the core building blocks, right? You've got activities, those are your screens, what the user sees.
The UI, basically.
Yep. Then services for background stuff, no UI usually.
Things happening behind the scenes.
Exactly. Broadcast receivers, they listen for system-wide events like the battery getting low or something. And finally, content providers. That's how apps can share data with each other.
Right, securely sharing data. And each of these has its own purpose, its own life cycle.
Precisely. A carefully managed life cycle.
That activity life cycle,
Yeah.
that always felt like a critical dance to get right. You have on create, the initial setup,
Yep, that's the very start. Setting up layouts, maybe initial data loading.
then on start, making it visible, getting ready.
Right, it's visible, but maybe not interactive yet.
Then on resume, when it's fully in the foreground, the user's interactive.
Correct, that's the active state.
Then on pause, that's when the user's leaving.
Right.
Might still be partly visible.
Yeah, like if a dialogue pops up over it, it's losing
This
focus.
pop means it's completely hidden.
Off screen, yeah.
And finally, on destroy, just before it's gone for good.
Cleanup time before it's removed from memory. You know, what's interesting is that subtle difference on create versus on start.
Yeah, tell me about that.
On create happens just once for that activity instance. Initial setup, that's it. But on start, that gets called every single time the activity becomes visible.
Ah, so if I navigate away and come back, on start runs again, but not on create.
Exactly. So any UI setup that needs to happen every time it becomes visible on start is often the place.
Okay, key difference. On create is once, on start is for each time it appears.
You got it. Initial setup versus visibility setup.
Now, here's a quirky one. What if you call finish right inside on create?
Ah, yeah. That short circuits things.
How so?
Well, if you call finish in on create, it basically skips on start. On resume, on pause, on stop.
Jump straight to the end?
Straight to on destroy.
Yeah.
It's like the activity realizes immediately, nope, don't need to run.
Yeah.
Maybe some validation failed or a condition isn't met.
A quick exit ramp. Makes sense.
Exactly.
Okay, saving state. Screen rotations, configuration changes, on save instant state, and on restore instant state. Feel a bit like magic sometimes.
Yeah. They're vital, though, especially
mean-
for rotations.
So on save instant state, that's called just before the activity might be destroyed, right? To save its state.
Right. Just before it goes away temporarily. Saves the dynamic state into a bundle.
And importantly, our notes mention if you explicitly call finish, this save doesn't happen.
Correct. If you're intentionally finishing it, the system assumes you don't need to save the state.
Okay. And then on restore instant state comes in after on start.
Yep, after on start, to bring back that save state from the bundle. You can also grab that same bundle and on create, if you prefer.
So the key is it saves state across temporary things like rotations, but not when I decide to close the activity.
Precisely. Like text in an input field during rotation,
Yeah.
that gets saved and restored.
Got it. Okay, fragments. Mini activities inside an activity.
That's a good way to think about it. They have their own life cycle, similar but tied to the activities.
And managed by the fragment manager.
Right.
I always saw fragments as key for, adaptable UIs. Reusability is huge.
Absolutely. Great for modularity and essential for those multi-pane layouts on larger screens like tablets.
And their life cycle, it's tied closely to the host activity, right? Like on attach.
On attach when it connects to the activity, on detach when it disconnects. It mirrors the activity's life cycle events in many ways.
Okay, swiping between fragments like in a view pager. We've got fragment pager adapter and fragment state pager adapter. What's the core difference there?
So fragment pager adapter, it keeps the actual fragment instances loaded in memory,
Okay.
but it destroys and recreates their views as you swipe away. Good for a small, fixed number of fragments.
Because creating fragments is heavier than just views.
Potentially, yeah. Now, fragment state pager adapter is different. It actually destroys the fragment instances when they're not visible.
Oh, completely gone.
Well, it saves their state, but the instance itself is gone. Much better for memory if you have a lot of fragments.
Like a big image gallery or something?
Exactly. So pager adapter keeps fragments in memory. State pager adapter saves state and destroys fragments to save memory.
Makes sense. Now, fragment transactions, add versus replace. What's the impact, especially on lifecycle and the backstack?
Okay, replace. Think of it as clearing out whatever's in the container and then adding the new fragment.
A clean swap.
Right. The fragment that got replaced is on destroy view, gets called. If you hit back later, it's on create view, will run again.
Add.
Add just puts the new fragment on top. Existing fragments underneath might get paused, on pause, but their views are still there, just maybe hidden.
Like stacking paper.
Kinda, yeah. And add to backstack is crucial here. If you add that to your transaction, whether it's an add or replace, it saves that transaction state.
So the back button works as expected.
Exactly. It lets the user navigate back through the fragment states.
Yeah.
So replace is a swap, add is layering, and add to backstack makes back navigation work.
Got it. Replace feels more common, maybe? Like
Yeah.
swapping out the main content area?
Often, yes. But add has its uses, like for overlaying dialogues or temporary views.
What about retained fragments? They sound a bit odd.
They are a special case. You tell the system not to destroy this fragment instance during a configuration change, like a rotation.
So it survives.
The instance itself survives. Its onCreate is skipped when the activity is recreated. But methods like onAttach and onActivityCreated still get called,
Why would you do that?
usually to hold on to data. Maybe a complex object, results from a long background task. Stuff you don't want to reload just because the screen rotated.
So the data persists, but the UI part still needs handling.
Exactly. The view hierarchy is still destroyed and recreated. You still need to manage that. But the fragment instance with its data sticks around.
Interesting. Saves reloading data across rotations. Okay, last bit on Android fundamentals, activity launch modes. Specifically, single task. How does that work?
Right, single task.
Yeah.
This one's about managing how activities exist within tasks, which are like stacks of activity. If you launch an activity marked as single task, the system first looks. Is there already an instance of this activity anywhere, in any task stack?
Checks everywhere.
Yep. If it finds one, it brings that existing instance's task to the front, and critically, it clears any activities that were on top of it in that task.
Clears the stack above it.
Right. Then, the new intent that tried to launch it gets delivered to that existing instance via its onNewIntent method. No new instance is created.
And if it doesn't find one?
Then it creates a new task and makes the single task activity the root of that new task.
So the core idea is ensure only one instance exists, potentially across different tasks, and bring it forward.
Exactly. It guarantees uniqueness and brings the existing one to focus, delivering any new info via onNewIntent.
Got it. Like a main dashboard screen, maybe you only ever want one.
Okay.
Let's shift gears. Kotlin essentials, lots to cover here. First, val versus const_val, and latinate versus lazy.
Right. So val is your standard read-only property. Assigned once, can't be reassigned.
Immutable reference.
Yep. Now, const_val is stricter. It's a compile time constant. Its value must be known when you build code.
Like a hard-coded string or number.
Exactly. And the compiler actually inlines the value wherever you use it. Use it for true constants, like maybe a version number or a fixed key. Otherwise, val is for runtime read-only values.
Okay. Val runtime read-only, const_val compile time constant. Now, latinate and lazy.
Both deal with initializing properties later.
Yeah.
Latinate is for non-nullable var properties. You promise the compiler, hey, I will initialize this before I ever try to use it.
Like injecting a dependency after the constructor.
Perfect example, if you try to access it before initializing, you get an exception.
Okay, and lazy.
Lazy is for val properties. It uses a lambda to define how the value is calculated, but that calculation only happens the first time you access the property.
Deferred initialization.
Exactly. The result is then cached, so subsequent accesses just return the cached value. Great for expensive initializations you might not always need.
Performance optimization, essentially.
Or managing dependencies that are only needed sometimes. So latinate is a promise for non-null vars. Lazy is deferred calculation for vols.
Got it. Lambdas and higher order functions. These feel very Kotlin. Concise code.
Very much so. A lambda is just an anonymous function, a block of code you can treat like a value, pass it around, store it.
Like a callback function, but written in line.
Right. And a higher order function is simply a function that either takes another function as a parameter or returns a function.
Functions operating on functions.
Yep. Leads to really expressive patterns like collection operations, map, filter, or defining custom listeners easily. Very powerful for reducing boilerplate.
Makes sense, like passing a sort rule into a sort function. Okay, object versus companion object. Both seem singleton-ish.
They are related to single instances, yeah.
Yeah.
An object declaration is a singleton. You define it, and you get exactly one instance of it, accessible directly by its name.
The object itself is the singleton.
Correct. A companion object is declared inside another class. It's a singleton object associated with that class.
Like static members in Java.
Very similar, yes.
Okay.
Its members can be accessed using the class name directly, often used for factory methods or constants related to the class.
So object for a standalone singleton, companion object for static-like members tied to a specific class.
That's a good summary.
What about those scope functions? Let, apply with run also. They look like shortcuts.
They are, essentially, syntactic sugar to make code acting on an object cleaner and more readable.
How do they differ?
Mainly in two ways. How they refer to the object inside the lambda, as it or this, and what they return, the object itself or the result of the lambda.
Oh.
For example, let the uses it and returns the lambda result. Apply uses this and returns the object itself, great for configuration. Knowing the nuances helps pick the one that makes your intent clearest.
So it's about clarity and conciseness when working with an object's context. Cool. Extension functions, adding stuff to classes you don't own.
Exactly. Super useful. You can define a function outside a class, but call it as if it were a member of that class.
Without inheritance or modifying the original code.
Correct. Perfect for adding utility methods to, say, the string class or view class, or classes from libraries you use. It's like adding your own tool to an existing toolbox.
Very neat. Equality versus this trips people up.
Yeah, it's important. In Kotlin, checks for structural equality. By default, it calls the equals method. Are the contents the same?
Like comparing the values inside two data objects.
Exactly. Whereas checks for referential equality, do these two variables point to the exact same object instance in memory?
Are they literally the same object?
Yep. So 4 looks the same, for 4 is the very same.
Got it. Structural versus referential. Now, sealed class versus enum. Both seem to represent restricted sets.
They do, but with key differences. An enum is a fixed set of named constants, each being a single instance. Think days of the week, simple states.
Like success, error, loading.
Right. Simple values. A sealed class also defines a restricted type hierarchy, meaning all direct subclasses must be declared in the same file. But the subclasses of a sealed class can be full-blown classes themselves. They can have multiple instances, hold different data, have their own state.
Ah, so more flexible than enums.
Much more. Think of representing network responses. Success, data, user, or error message you create. Each subclass carries different data. Enums are for simple sets. Sealed classes for restricted hierarchies where subtypes can have state.
Perfect for things like representing UI state variations. Okay, inline functions, croc inline, no inline. Sounds like compiler magic.
It is compiler optimization. An inline function tells the compiler, instead of actually calling this function, to just copy its code directly into the place where it's called.
Reduces function call overhead?
Potentially, yes. Can improve performance slightly sometimes, but lambdas passed to inline functions also get inlined by default.
Okay.
If you need to pass that lambda somewhere else, like store it in a variable or pass it to another function that isn't inlined, you mark that lambda parameter with noinline. It tells the compiler not to inline that specific lambda.
Prevents inlining when needed. What about cross-inline?
Cross-inline is for lambdas passed to inline functions that are called, but not directly. Maybe inside another lambda or an object expression within the inline function. It adds a restriction that lambda cannot do a non-local return, like returning from the outer function.
Okay, subtle control over lambda behavior within inline functions. Probably less common day-to-day.
Generally, yeah. Inline itself is the main concept.
Yeah.
Noinline and cross-inline handle specific lambda edge cases.
Got it. Lastly, for Kotlin basics, synchronization.
Yeah.
How do we handle shared resources concurrently?
Well, Kotlin runs on the JVM, so you still have access to all of the standard Java tools, synchronized blocks, locks from java.util.concurrent, atomics, etc.
The classic stuff.
Right. But Kotlin's coroutines also offer higher-level ways to manage concurrency in shared state, often making it easier and less error-prone than raw threads and locks. We'll dive more into coroutines later.
Okay, standard Java tools plus coroutine magic. Cool. Let's bridge into Android specifics with Kotlin and Jetpack, those file formats, JR, AIR, DX, APK. What's the story?
Okay, think of them as packaging levels. A JAR, draw archive, is basic.
Okay.
Just compile Java or Kotlin.class files and maybe some metadata. Standard library format, no Android resources.
Just the code.
Pretty much. An AAR, Android Archive, is the format for Android libraries. It has the code, plus Android resources like layouts, drawables, assets, and its own Android manifest snippet.
So code plus Android-specific stuff for libraries.
Exactly. DAX files, Dalvik executable, are what your code gets compiled into for the Android runtime, RA, previously Dalvik. It's optimized bytecode for Android devices. Your app and its library dependencies all end up as DEX files.
The executable code for the device.
Yeah. And finally, the APK Android Package Kit is the actual app file you install. It bundles the DAX files, all the resources compiled, assets, native libraries, and the main Android manifest.xml.
The final installable packet. So JAR, code, DAFA AR, Android lib. DAFA AX, compiled bytecode, DAFA APK, installable app.
That's the progression.
Clear. Now, dependencies in Gradle.implementation, APA, compile only, runtime only, when to use which?
Implementation is your default, your go-to. It means your module needs this dependency to compile and run, but it doesn't expose that dependency to other modules that depend on your module.
Keeps it internal. Hides the details.
Exactly. Good for encapsulation and faster builds because changes in the hidden dependency don't force recompilation of modules further up the chain.
Okay. What about Appuli?
Appuli is like implementation, but it does expose the dependency transitively. Use this if your module's own public API, like public functions or classes, uses types from that dependency.
So if my library returns a type from another library, I need a Appui.
Correct. Otherwise, consumers of your library wouldn't be able to compile.
Makes sense. Compile only.
That means the dependency is needed only during compilation. It won't be included in the final runtime class path or the APK.
Like annotation processors.
Perfect example. Things that generate code or do checks at build time but aren't needed when the app runs.
And runtime only.
The opposite. Not needed for compilation, but required when the app actually runs. Less common, but maybe for specific implementations chosen at runtime, like SLF4J logging backends.
Okay. Implementation, default, internal, AP, expose, compile only, build time, runtime only, runtime. Got it. Lastly here, Jetpack Compose, the new UI toolkit.
Yeah. Compose is Android's modern declarative way to build UIs, instead of manually manipulating views step by step.
Like with XML layouts and find view by eye.
Right. Instead, you describe what your UI should look like based on the current state, using Kotlin functions, composables.
You declare the UI.
Exactly. And when the state changes, Compose intelligently figures out what parts of the UI need to update and re-renders just those parts. It's all Kotlin, aiming for faster, more intuitive UI dev.
The future, arguably. Okay, let's dive into asynchronous programming. Kotlin coroutines, big topic. How are they fundamentally different from plain old threads?
Okay, the core idea. Coroutines are lightweight concurrency. Think of them as virtual threads or cooperative tasks that run on top of actual threads.
So one thread can run many coroutines.
Yes, very efficiently. The key is they are suspendable. A coroutine can pause its execution at certain points, suspension points, without blocking the underlying thread.
Ah, the thread is free to do other work, like run another coroutine.
Precisely. This avoids wasting threads just waiting for I/O or delays. They also make context switching, like moving from a background thread to the main UI thread, much simpler. Lighter, suspendable, more efficient than raw threads.
Sounds powerful. What about global scope? Seems like a broad scope to launch things in.
It is. Global Scope launches coroutines tied to the entire application's lifecycle. They keep running as long as the app process is alive.
Sounds risky.
It can be. If the component that launched the coroutine, like an activity, is destroyed, but the coroutine in Global Scope is still running a long task, you could easily get memory leaks or unexpected behavior.
Orphan tasks.
Exactly. It should be used very, very sparingly. The preferred way is structured concurrency, using scopes tied to component lifecycles, like view model scope or lifecycle scope. Avoid global scope mostly.
Okay, noted. Use lifecycle-aware scopes instead. Now, delay in a coroutine. It looks like thread.sleep, but you said coroutines are non-blocking.
Crucial difference, delay, is a suspending function. When a coroutine calls delay 1000, it suspends itself for 1 second.
It pauses itself.
Yes, but the thread it was running on is not blocked. That thread is immediately free to run other coroutines or do other work. After the delay, the coroutine scheduler will resume the suspended coroutine on an appropriate thread.
Whereas thread.sleep 1000 just freezes the thread for a second.
Completely blocks it. Nothing else can run on that thread. So delay is cooperative and efficient. Thread.sleep is blocking and inefficient for concurrent tasks.
Big difference. Suspending versus blocking. Okay, starting coroutines, launch versus async.
Two main builders. Launch is for fire and forget tasks. You start a coroutine, it does its work, but you don't directly expect a result back from it.
Like updating UI or writing to a database without needing immediate feedback?
Yeah.
Exactly. Launch returns a job object, which
Mm.
represents the coroutine's life cycle. You can use the job to cancel it, for example.
Okay, and async.
Async is used when the coroutine is expected to compute and return a result. It also returns a job, specifically a deferred, which is a job with an added await function.
Well, wait to get the
Okay.
result.
Yes, await
Right.
itself is a suspending function. You call it to pause the current coroutine until the async task completes and its result is available.
So launch for side effects, async when you need a return value eventually.
Perfect summary.
What exactly is a suspend function then? We keep saying suspending.
A suspend function is just a regular Kotlin function marked with the suspend keyword. This marker tells the compiler that this function can potentially pause execution at suspension points and resume later.
It enables the non-blocking magic.
It's the core building block and the key rule. You can only call a suspend function from another suspend function or from within a coroutine builder, like launch or async.
Keeps the suspending world contained.
Right. It ensures these non-blocking operations happen within the managed context of a coroutine.
Okay. Coroutine contexts and dispatchers. Default, unconfined, IO, main. Which thread pool for what job?
The dispatcher is part of the coroutine context, and it determines which thread or threads the coroutine runs on. Dispatchers. Default uses a shared pool of background threads, sized based on CPU cores. Good for CPU-intensive work.
Heavy computation.
Yep. Dispatchers.io uses a larger shared pool of threads designed for I/O operations, network calls, disk access. These threads spend a lot of time waiting, so you can have more of them.
Network, database stuff.
Exactly. Dispatchers.main on Android is tied to the single main UI thread. Use this only for updating the UI or interacting with UI components.
Crucial for Android UI. What about unconfined?
Unconfined is a bit special. It starts the coroutine on the current thread, but if it suspends and resumes, it might continue on whatever thread the resuming operation used. It jumps around. Generally avoid it unless you know exactly why you need it, as it can lead to unpredictable behavior.
Okay, stick to default for CPU, IO for IO, main for UI. Got it. Now, with context. Looks like another way to switch threads.
It is, but it's different from launching a new coroutine. With context is a suspending function itself. You call it within an existing coroutine to switch to a different dispatcher for just a block of code.
Like, I'm on main, but need to do a quick database read.
Perfect example. You'd do with context dispatchers.io. The coroutine suspends, the block runs on an IO thread, and when it's done, the result is returned, and the coroutine resumes back on the original dispatcher. Main in your example.
So it's a temporary switch within the same coroutine, and it waits.
Exactly. It waits for the block to complete before the coroutine continues. No new coroutine is created, just a context shift for a specific task.
Handy. Now, run blocking. The name implies blocking. Why use this in a non-blocking world?
You're right, it does block. Run blocking starts a coroutine and blocks the current thread until that coroutine completes.
Seems counterintuitive.
It is for general use, especially on the main thread, definite UI freeze. But it has specific uses,
Like what?
mainly for bridging the non-suspending world with the suspending world. In main functions of simple programs, or very commonly, in unit tests where your test framework expects synchronous execution, but you need to call suspend functions.
Ah, testing makes sense. Calling suspend code from a regular test function.
Precisely. Or sometimes integrating with legacy blocking APIs. But use it sparingly, mostly for tests and top-level bridging.
Okay, a specific tool for specific boundary cases. Now, coroutine scopes, lifecycle scope, view model scope. Why are these so important in Android?
Structured concurrency. These scopes tie the lifecycle of coroutines to the lifecycle of Android components.
So they get cleaned up automatically.
Exactly. Coroutines launched in lifecycle scope from an activity or fragment are automatically canceled when that component's lifecycle is destroyed. For example, in onDestroy.
Prevents leaks from running coroutines after the UI is gone.
Yes, and view model scope is tied to a view model. Coroutines launched in it are canceled when the view model's uncleared. Method is called.
So when the view model is truly finished,
Right. It's crucial for preventing memory leaks and ensuring background work doesn't outlive the component that needed it. Automatic cancellation is a huge win.
definitely. Okay, error handling. Try-catch works, but what about coroutine exception handler and supervisor scope?
You can always use standard try-catch blocks inside a coroutine to handle exceptions where they happen.
Local handling.
Right. Coroutine exception handler is different. It's an element you can add to the coroutine context when you launch a coroutine. It acts like a global handler for uncaught exceptions within that coroutine or its children. good for logging crashes or default error handling.
A top-level safety net.
Kinda, yeah. Now, supervisor scope, or using a supervisor job in your scope, changes how parent coroutines handle failures in their children. Normally, if one child coroutine fails, it cancels its parent and all its siblings.
Everything comes crashing down.
Yes, but a supervisor scope isolates failures. If a child launched within it fails, it doesn't cancel the supervisor scope itself or any other children.
So other parallel tasks can continue.
Exactly. Useful when you have independent tasks running concurrently and one failing shouldn't stop the others. Note that for async within a supervisor scope, you still need to try catch the await call because the exception is stored in the deferred until you await.
Okay, so try catch locally, exception handler for uncaught, supervisor scope to isolate failures and parallel tasks. Got it. Let's quickly nail down suspending versus blocking again. Core difference.
Suspending. The coroutine pauses, but the thread it was on is free to do other work, like run another coroutine. It's cooperative.
Right.
Blocking. The thread waits, frozen, until the blocking operation completes. It cannot do any other work.
Efficiency is the key. Suspending frees the thread.
Precisely. Coroutines leverage suspension for high concurrency with fewer threads. Suspending is efficient. Blocking halts the thread.
Crystal clear. Jobs, cancellation, timeouts, brief overview. Our notes are a bit light here.
Sure. A job represents the life cycle of a running coroutine. You get it back from launch. You can use it to check if it's active or cancel it.
Control over the coroutine.
Yep. Cancellation itself is cooperative. Calling cancel sets a flag, but the coroutine code needs to actively check is active or use built-in suspending functions like delay, yield, I/O operations, which check for cancellation internally.
So the coroutine has to play along to be canceled.
Right. It won't just stop mid-instruction unless it checks. Timeouts are handled with functions like with timeout or null. They run a block of code and throw a timeout cancellation exception or return null with timeout or null if it doesn't complete within the specified time. Automatically cancels the job.
Prevents indefinite waiting. Okay. Jobs control, cancellation is cooperative, timeouts enforce limits. Moving on to Kotlin flow. Asynchronous data streams. How is it different from just one suspend call?
Suspend function performs an async operation, returns one value or nothing. Flow represents a stream of values that can be emitted asynchronously over time. 0, 1, or many values.
Single result versus a sequence?
Exactly. Think network requests for user data, suspend function, versus listening for location updates, flow. Flows are also cold by default.
Cold.
Meaning the code inside the flow builder doesn't run and no values are emitted until someone starts collecting from it, observing it. Each new collector typically triggers the flow execution again from the beginning.
So suspend for one-shot async results, flow for async streams of data. Got it. Now, state flow and shared flow. Implementations of flow.
There are spiral types of hot flows, meaning they can have multiple collectors and might emit values even if there are no collectors. State flow is designed specifically for holding and emitting state.
Like UI state.
Perfect use case. It always has a current value, and when a new collector starts observing, it immediately gets the latest emitted state. It also only emits distinct values sequentially.
So subscribers always get the current state. What about shared flow?
Shared flow is more general purpose for broadcasting values to multiple collectors. You have more configuration options. You can control how many past values are replayed to new collectors, the replay cache, and how it buffers values if collectors are slow.
More flexible broadcasting.
Right. Good for one-time events where you don't necessarily want every new subscriber to get the last event, like showing a snack bar message, or when you need fine-grained control over buffering and replay for multiple concurrent collectors.
So state flow for representing current state, UI state, shared flow for broadcasting events or data streams with configurable replay buffering. The state holding part of state flow is key.
Absolutely. State flow guarantees the latest state is available.
Cool. Let's pivot to security. SSL pinning. First, what's SSL and how does pinning stop man in the middle?
Okay, SSL, Secure Sockets Layer, or more commonly now TLS, Transport Layer Security, is the standard protocol for creating an encrypted link between a client, your app, and a server.
Secures the communication channel.
Right. Prevents eavesdropping. Now, normally, your app trusts the device's built-in list of certificate authorities, CAs, to verify the server certificate.
Checks if it's signed by a trusted authority.
Exactly. SSL pinning adds an extra layer. Your app doesn't just trust any certificate signed by a known CA. Instead, it checks if the server certificate, or its public key, matches a specific certificate or key that you've embedded or pinned within your app itself.
So it has a specific fingerprint it's looking for.
Precisely. If an attacker somehow tricks a CA into issuing a fraudulent certificate for your domain, or installs a malicious root CA on the user's device, pinning will still detect it because the presented certificate won't match the one pinned in your app. It blocks that man-in-the-middle attack.
Ah, verifies the server directly against a known good copy.
Huh. We have root, intermediate, and leaf certificates. What are the trade-offs of pinning each?
Good question. Pinning the root CA certificate gives you the longest lifespan. Roots are valid for decades, usually, so less app update maintenance.
Oh, but
But it's the least secure.
Right.
If that root CA gets compromised, any certificate they issue could potentially be used to impersonate your server, and your pinning wouldn't catch it. You're trusting that entire CA.
Okay. What about the leaf certificate, the server-specific one? That's the most secure. You're pinning the exact certificate for your server. Maximum control.
Downside.
Leaf certificates have the shortest lifespan, often just a year or even less. So you have to update your app with a new PIN certificate key every time it's renewed. More maintenance.
High security, high maintenance, and intermediate.
Intermediate certificates sit between the root and leaf. Pinning an intermediate offers a balance. Lifespan is longer than the leaf, shorter than the root. You're trusting the intermediate CA, often related to your hosting provider or specific vendor. It's a common middle ground.
Root, long life, low security. Leaf, short life, high security. Intermediate, balanced.
Yeah.
Got it. How do we actually do this in Android?
Two main ways. If you're using retrofit with OKHTTP, very common. OKHTTP has a certificate pinner builder. You provide the domain name and the SHA-256 hash of the public keys you want to pin.
Programmatic pinning in your network client setup.
Right. The other way is declarative, using Android's network security configuration file. It's XML file, network security config.xml, you add to your app's resources.
Configure it in XML.
Yep. You define domains and specify the certificate pins, again, usually SHA-256 hashes, within the XML. The system then enforces these pins automatically during the SSL handshake.
Code via OKHTTP or declarative via XML. Nice. What about sensitive data inside the app? Tokens, keys, etc. How to store those securely?
Never store them in plain text, shared preferences, or databases. Jetpack Security Library is the way to go here.
What does it offer?
It provides encrypted shared preferences. It looks and feels like regular shared preferences, but it automatically encrypts both the keys and the values before saving them.
Transparent encryption.
Exactly. It uses a master key to handle the encryption. And this master key itself should ideally be generated and stored securely in the Android Key Store system.
Hardware-backed storage if available.
Yep. The Key Store can leverage hardware-backed security, like the T-Trusted Execution Environment, on many devices, making it very hard for attackers to extract the encryption key, even with root access. So use encrypted shared preferences with a master key stored in the Key Store.
Fundamental security practice. Okay, shifting to architecture and best practices questions. Live data versus stateflow. We touched on stateflow. How does live data compare?
Live data is the older Android architecture component. It's an observable data holder, like Stateflow, but it's specifically lifecycle aware out of the box.
Meaning it only pushes updates when the observer, like a fragment, is active.
Exactly. It only updates observers in the started or resumed state. This avoids potential crashes if you try to update UI when the view isn't ready. It also holds the latest value, like Stateflow.
Sounds good for UI. Downsides.
Its integration with coroutines isn't as seamless as Stateflow. While there are helpers, Live Data Builder as Live Data, Stateflow is inherently built for the coroutine world. Live Data also has some quirks with transformations and combining streams.
So when to use which?
General guideline. Live Data is often fine, even good, for simple UI state observed directly in fragments activities where its automatic lifecycle handling is beneficial. Stateflow is more powerful and flexible, especially if you're deep into coroutines, managing state across layers, view model to repository, or need more advanced stream operations.
Live data for simple UI lifecycle needs, Stateflow for broader coroutine-based state management. Makes sense. Dependency injection HILT versus Dagger 2. Why prefer HILT?
Okay, DI itself is huge for modularity and testing, getting dependencies injected instead of creating them inside classes. Dagger 2 is the powerful established standard for DI on Android.
It's complex.
Can be, yeah. Lots of boilerplate setup modules, components, subcomponents. HILT is built on top of Dagger 2, specifically for Android to simplify things.
How does this simplify?
It drastically reduces boilerplate. It provides predefined components and scopes tied to standard Android lifecycles, at activity scoped, at view model scoped, etc. You just annotate your classes at Android entry point, at HILT view model, at inject, and HILT generates most of the Dagger code for you.
Easier setup, less code to write.
Exactly. Better integration with Jetpack libraries like View Model and Navigation. Easier testing setup too. Dagger 2 still offers more fine-grained control if you need complex custom setups, but for most Android apps, Hilt is faster to implement and easier to maintain.
Hilt, less boilerplate, Android-focused simplification.
Got it. How does View Model survive configuration changes? Where does the data actually live?
It's about the scoping. A view model isn't tied to the specific activity or fragment instance that gets destroyed and recreated on rotation.
It lives somewhere else.
It's associated with the activity fragment via the view model provider, which uses the component's lifecycle but retains the view model across configuration changes. Think of the view model store owner, which activities and fragments implement, holding on to the view model instance.
So the provider keeps it alive.
Yes, until the view model store owner is permanently destroyed, like the activity finishing or fragment being removed for good. Then, the view model's uncleared method is called for cleanup.
What about process death, if the whole app process is killed? Standard view models don't survive process death by themselves. For that, you need to use the save state handle, which is injected into your view model if you use Hilt or the right factory.
Save state handle.
Yep, it's basically a key value map, similar to the on-save instance state bundle, but tied to the view model's lifecycle and automatically saved restored by the system across both configuration changes and process death. Use it for critical UI state that needs to survive everything.
View model survives rotation via scoping. Save state handle handles process death persistence. Clear. Modularizing large apps. Recommended layer structure.
Yeah, for big apps, modularization is key for maintainability, build times, team collaboration. A common structure is layers. 1. Presentation layer, UI, activities, fragments, composables, view models, presenters, UI state management.
What the user sees and interacts with.
Right. 2. Domain layer, optional but recommended. Contains pure business logic, use cases, interactors. It orchestrates data flow between presentation and in-data layers. Shouldn't have Android framework dependencies?
Core logic, platform agnostic.
Ideally, yes. 3. Data layer, repositories, data sources, network API clients, local database DAOs, data mapping logic, handles where data comes from.
Fetching and storing data.
Exactly. Then, within or across these layers, you break things into modules, often by feature.feature.login.feature.profile, and by layer.core.ui.data.network.domain.
Feature modules depend on core data modules.
Typically, yes. Feature modules encapsulate everything for a specific feature. Core modules provide shared functionality. UI components, network setup, database setup, base classes. This improves build times. Gradle only rebuilds changed modules and their dependents, and separation of concerns. Use EPI versus implementation wisely between modules.
Layers for responsibility, modules for feature shared code, good structure, Jetpack Compose recomposition optimization, remember savable, derive state of.
Okay, Compose recomposes, reruns composable functions. When the state objects, they read change. It's smart and usually only recomposes what's needed.
But sometimes we need to help it.
Right. Remember, it's fundamental. It caches the result of a calculation within a composition. If the composable recomposes, remember, gives back the cached value instead of recalculating, unless its input keys change. Essential for performance.
Caches across recompositions. What about rotation?
Remember, does not survive configuration changes or process death. For that, you need Remember Savable. It works like Remember, but also saves the state into the bundle, like on Save Instance State, so it persists across those events.
Like remember plus persistence.
Exactly. Use it for UI state that needs to survive rotation, like text field input or scroll position.
And derived state of.
This is an optimization. Imagine you have state A and state B, and your UI depends on some calculation involving both. C equals A plus B. If you just calculate C directly in the composable, it might recompose whenever either A or B changes, even if C's result doesn't change.
Wasted recomposition.
Potentially. Derived state of A plus B creates a new state object C that only notifies compose to recompose if its calculated value actually changes. It avoids unnecessary updates when the inputs change, but the output remains the same.
Smart calculation based on dependencies. So remember, in composition cache, remember savable, survives rotation death, derived state of, optimized derived state calculation, got it. Error propagation in coroutine's best strategies.
We touched on parts. Generally, use try-catch for expected errors you can handle locally within a coroutine. Use coroutine exception handler on the top-level scope, like view model scope, for logging or handling unexpected, uncaught exceptions, the ones that would otherwise crash the app.
Local versus global handling.
Right. Use supervisor scope or a supervisor job when launching multiple independent parallel tasks, often with async. This prevents one task failing from canceling the others. Remember to still try catch the await calls for async within it.
Isolating failures.
And for flows, the catch operator is the idiomatic way. You chain it onto the flow before collecting, and it intercepts upstream exceptions, allowing you to emit a fallback value or handle the error gracefully.
Declarative error handling for flows.
Hmm.
Different tools for different spots. Okay, suspend function versus flow. Again, primary use cases. Simplified.
Suspend function for a single asynchronous operation that produces one result or none. Fetch user profile, save settings, perform calculation. One shot.
One result.
Flow. For a stream of asynchronous data. Multiple values over time. Observing database changes, getting continuous sensor data, handling user input events. A sequence.
Multiple values over time. Clear. Background tasks. Work manager, job scheduler, alarm manager, services. When to use which.
Okay, Work Manager is the modern, recommended solution for most deferrable, guaranteed background work.
Deferrable and guaranteed.
Meaning it doesn't have to run immediately, and Work Manager ensures it will run eventually, even if the app closes or device restarts. It handles constraints, network, charging, intelligently. Use it for syncing data, processing uploads, downloads reliably. API 14+.
The go-to for reliable background stuff.
Mostly, yes. Job Scheduler, API 21+, is what Work Manager uses under the hood on newer devices. You could use it directly if you need finer control than Work Manager provides, but usually WM is easier.
Lower level option.
Alarm Manager, API 1+, is specifically for scheduling tasks to run at a specific time or on a repeating interval. Think calendar reminders, alarm clocks. Not great for general background work, as it can be resource-intensive if misused.
Time-based triggers.
And Service, API 1+, is for tasks that need to run while the user is potentially interacting with the app indirectly, or for longer-running tasks that shouldn't be killed immediately when the app goes to the background. Think music playback or an ongoing download the user is monitoring. Foreground services require a persistent notification.
Ongoing, potentially user-aware tasks. So, Work Manager for reliability, Job Scheduler for fine control, Alarm Manager for time, Service for ongoing foreground tasks.
That's a great summary. Work Manager covers most modern needs well.
Diagnosing memory leaks, key steps and tools.
Leaks are nasty. First tool, Android Studio's Memory Profiler. Watch the memory graph as you use the app, especially navigating back and forth from activities fragments. Look for the heap steadily growing without coming back down, classic leak sign.
Graph goes up and never comes down.
Right. Then, force garbage collection, GC in the profiler. If memory doesn't drop, capture a heap dump, analyze the dump to see which objects are holding on to memory unexpectedly. Look for references to destroyed activities or fragments.
Analyzing the heap dump. What else?
Weakanary. It's a library you add to your debug builds. It automatically detects leaks of activities, fragments, view models, etc., and gives you a notification with the reference path showing what is holding on to the leaked object. Invaluable.
Automatic detection in debug. Nice. Common causes.
Static references to contexts, unregistered lists and receivers, inner classes holding implicit references to the outer class, like an activity, coroutines or RxJava subscriptions tied to a shorter lifecycle that weren't canceled.
Gotcha. Profiler, heap dumps, leak canary, be vigilant, navigation component. How does it simplify things? Limitations.
It hugely simplifies fragment management for navigation. You define destinations, fragments or activities, and actions, transitions between them, visually in a navigation graph XML file.
Visual flow definition.
Right. It handles the fragment transaction boilerplate, manages the backstack correctly based on your graph, and provides type-safe argument passing between destinations using the SafeArgs Gradle plugin. Supports deep links, too.
Takes care of a lot of tricky fragment stuff. Limitations.
For very complex, highly dynamic navigation flows, where the next screen depends heavily on runtime conditions, the static XML graph can sometimes feel limiting. You might need more custom logic or alternative approaches. Also, the XML file itself can get large and maybe hard to manage in huge apps with hundreds of screens. But for most standard app flows, it's excellent.
Great for standard flows, might need care with extreme dynamism, offline-first architecture, core ideas, tools.
Key idea. Your app should work first from local data, providing a seamless experience even offline. The network is for syncing, not the primary source for the UI.
Local data is king.
Exactly. Single source of truth principle, usually applied to the local database. The repository pattern is central. It abstracts data access, deciding whether to fetch from local cache or remote network.
Repository manages local versus remote.
Yep. Typical flow. UI requests data from repository tries local cache or GROOM database. If data is present fresh enough, return it immediately. Optionally, trigger background network fetch, e.g. via retrofit. If network fetch succeeds, update local cache. UI observe local cache, often via slow or live data, and updates automatically when cache changes.
UI observes the local database.
Right. Tools. Room for the database, retrofit for network, Kotlin Flow for reactive data streams from Room, and for managing async ops, Work Manager for reliable background syncing when network is available.
Room, retrofit, flow, Work Manager, the offline stack.
Got it. Quick recap. Compose, remember savable, derive state of.
Remember, caches a value across recompositions within the current composition lifetime. Lost on rotation.
Okay.
Remember savable. Like remember, but also say it restores the value across configuration changes and process death.
Persistent cache.
Derived state of. Creates a derived state that only triggers recomposition when its output value actually changes, even if underlying inputs change. Performance optimization for calculated state. Smart state calculation. Perfect. Finally, unit testing the repository layer. Strategy.
Goal. Test the repository logic in isolation. Don't hit real network or database in unit tests.
Locking.
Exactly. Use mocking frameworks like Mock, popular in Kotlin, or Mockito. Mock your data sources, DAOs, API services that the repository depends on.
Inject mocks.
Yep. Inject these mocks into your repository instance in the test setup. Then write tests for different scenarios. Verify that when you call getUser, the repository correctly calls the DAO's getUser by the method.
Yeah.
Verify it handles successful API responses correctly. Verify it handles network errors or database errors gracefully.
Test the logic and interactions. Tools.
Gene 4 or 5 for the test framework. For testing suspend functions and flows, use the Kotlin coroutines test library. It provides run test or run blocking test in older versions, builders and test dispatchers to control virtual time and run coroutines synchronously in tests.
Control coroutine execution in tests.
Right. Organize tests, maybe a user repository test class for user repository.
Yeah.
Use clear test names describing the scenario. Get user success returns user data. Get user appear throws exception.
Isolate with mocks. Verify logis interactions. Use JUnit plus coroutine test lib. Organize clearly. Solid plan.
And a common organizational pattern is to have a dedicated test directory mirroring your source structure. For example, repository user repository test.
Well, this has been quite the journey, a really in-depth exploration. We've covered a huge amount of ground and word fundamentals, Kotlin core ideas, async programming, security, architecture.
Yeah, it's a lot. And honestly, each of these sections, we could easily spend a whole section just on that one topic.
Oh, absolutely. This was about hitting the essentials, giving you that solid foundation.
Exactly, a foundational understanding of the key pieces.
So for you listening, as you kind of digest all this, maybe think about which of these concepts really clicks or stands out for your work.
Yeah, what feels most relevant right now?
Right. What area, if you dove deeper, could have the biggest impact on your projects? Maybe that's your next step, picking one area and exploring it further.
That's a great way to approach it. Keep learning, keep applying it. That's how you really master this stuff.
Couldn't agree more. A massive thank you to our expert guide for breaking down these vital, complex topics so clearly.
My pleasure. It was fun to talk through it all.
Until our next deep dive, keep exploring, keep building.